Alright, hi guys, I am at jury duty, so I made a video for today's lesson. I'm hoping to get the video done in one video, I guess I should say, instead of having to split it up, but it all depends on the amount of time. Just remember you can pause the video, so as we get to some of the examples, just for time, I'm going to just talk right through one example to the next. So you might want to pause the video so that you can take the notes and do the examples that you need to do. All right, so we're going to look at even and odd functions today. And first thing, we're going to look at this different ways. One is algebraically. So you know a function is even if all of the exponents are even. So what we're going to do is we're going to look at, if you can think of the polynomials that we've been working with this year, we're going to go through and look at the exponent on the variable. And as long as they're all even numbers, then the function is even. So you can probably take a guess that if the function is odd, that's because all of the exponents were odd numbers. And then there's always the case, well, what if I have some of both? So that would be the situation that's neither. So over the next few slides, I have quite a few examples to go through with you. So again, what we're doing is we're looking at the exponents, and if the exponents are all even numbers, the function's even. If the exponents are all odd numbers, then the function is odd. And if it's a mixture, then it's neither even nor odd. All right, now the one thing you have to be careful of are the constant terms. Constant terms actually do have a variable on them, but the variable would be x to the 0. And hopefully you remember from last year that anything to the 0 power is equal to 1. So x to the 0 is just the same thing as multiplying by 1. So constant terms are always considered even. So just remember, constant terms are considered even. All right, you can also decide if a function is even or odd by looking at the graph. So the function is going to be even if you can reflect the function across the y-axis. So under this it says you can fold it hot dog style. So if you could fold on the y-axis and the right side matches up with the left side, then the function's even. It's going to be an odd function if you can rotate it 180 degrees. Now, the one thing about this is that rotating it 180 degrees has to go through the origin. So basically, if you could spin it around 180 degrees and it will land back on top of itself, then that function is odd. If anything else happens, then it's neither. So if you can't reflect it, it's neither. If you can't rotate it, it's neither. So those are the two situations that we're looking for. All right, here's example number 1, even, odd, or neither. So looking at this function, I'm going to check out the exponents. This one has an exponent of 3. This variable has an exponent of 1. 1 and 3 are odd numbers, so this function is odd. Here's another example. Again, I'm going to look at the exponents. This exponent is a 2. When I go over here, this is a constant term, so remember, constant terms count as x to the 0. Constant terms are even. So I have an even here, so this function is even. All right, here's one looking at the graph. So we looked at this one the other day, the absolute value graph. But the left side is reflection of the right side over the y-axis. So this function is even. Here's your next graph. Even, odd, or neither. Well, when I look at this one, I can tell that I cannot reflect it over the y-axis. So I know it's not even. I could rotate that curve 180 degrees, but since it's not going through the origin, it's not going to land on itself. So this is an example of a neither. All right, 2 more examples. The one on the left, again, I'm looking at the exponents. This is even. This one is considered even, so this function is even. Example on the right. x to the third is odd, and x is x to the first. Those are both odd numbers, so this function is odd. All right, here's a few more examples. This function has an exponent of 3, so this function is odd. This function has an exponent of 3, which is odd, so this function is odd. This has an exponent of 2, and then remember, constants count as even exponents. So those two terms are both even, so the function is even. Looking at this one, here I have an odd exponent, here I have an even. Whenever we have a mixture, it's neither. The next example, this exponent is odd, this exponent is odd, so this function is odd. This exponent is odd, this exponent is odd, but this one is even. Constant terms are even, so that function is neither. All right, looking at the graph, I want to ask myself if I can reflect this over the y-axis, or can I rotate it 180 degrees? And what I can do on this one is reflect over the y-axis. That makes this first example even. On this one, I can definitely tell it's not an even function because I cannot reflect over the y-axis. Oh, I might have said x-axis on the last one. I hope I didn't. But I could rotate this 180 degrees. Since it's going through the origin, I can rotate this function 180 degrees. It will land on itself, which means that this function is odd. Looking at this one, I can reflect over the y-axis. That makes this one even. This one, I cannot reflect over the y-axis. It's not going through the origin, so it's neither. This one is not a reflection. It is a rotation of 180 degrees. If I rotated this 180 degrees, it would come back up here, and it is going through the origin, so this function is odd. Okay, you're given these dots, and you're told that they are part of an even function. So what points do you know are also part of the function? Well, let's think about it. If a function is even, that means all the exponents are even. But we don't have an equation to look at, we have a graph. So an even graph would be a reflection over the y-axis. So what that means is that if this point is here, then it must have a partner reflected point over here. And the same thing with the green. If this point is here, so let's go back again. If this point is here and the function is even, then it has a partner reflection point over here. And then finally, looking at the blue one, if this point is on an even function, then there must be a reflected partner over here. Oops, sorry, I went the wrong way. To make it an even function. All right, same kind of question, except this time it's odd. So now what you need to do is think about what an odd function is on a graph. We know if we had the equation, we could look at the exponents, but we don't have an equation, we have a graph. So an equation, or sorry, the graph of an odd function means that these points could be rotated not once, but twice. Meaning, if I rotated this red point 180 degrees, it would end up down here. So, my points would look like this. All right, to go back again, if we had this green point and we rotated it 180 degrees, we would end up with another partner point out here. So what you're looking for on an odd function is to rotate the points you have 180 degrees. And to do that, you change the sign on the x and the y. All right, that covers even and odd functions. If you need to go back and replay the video, please do. And then you can go ahead and pick up today's assignment, which is similar to the examples we just went through. Good luck!